Oh, I have a new format today. The idea now is I'm going to show you if you were to log on to your computer at home, doing hours and hours of homework slaving away at home, how it should look when you go to the ministry site and download the free past provincial exams, which are very, very good indications of what the current exam will probably look like. Well, it'll look like it. The questions won't be the exact same, of course, but questions are similar from year to year, and exams formats typically are very, very consistent. So if I were to do a new Google search, I would just search for something like BC Math 10, and then I would find a website that looked like the government, gov.bc.ca right there. Oh no. Foundations in Pre-Calculus. That's not the one I want. So you can go to Examinations. Sample exams. Then you choose your year. I hope you know what grade you're in. That's important. Oh, I want this one. Get exams. And then all the info you need is right here. I've already pulled it up just for simplicity's sake. So I also want to tackle a couple questions and then show you, when you pull up the answer key, how to read and interpret this answer key just fairly quickly. Okay, so let's start with question 32. I'm also going to do this in a program where I can actually draw. Question 32. Oh, and by the way, this exam is not mine. It is copyrighted by the Ministry of Education in British Columbia, and I'm using it simply for educational purposes and not to my own benefit. If for whatever reason this video becomes extremely popular, I guess I'll have to give some money to the government. Okay, now, more importantly, triangles. Let's take a look here. So, what I want... Wait. Where did my pen go? Oh no, I had a pen, it was right here, and then it's gone. Oh, there it is. Never mind, sorry. Okay, so this is a bit of a trickier question about triangles. Which of the triangles below is a right triangle? And we know things about right triangles. Right triangles, oh, I don't have a very steady hand, but I'll do what I can do. They have, oh, okay, oh. Sorry, I'm not used to this, but, okay. Oh my gosh. Right triangles, ooh, okay. I'll draw it on a triangle. Let's cancel that one. They have that little square right here. Remember that square? That indicates that they are 90 degrees right here. This one may not be a right triangle. We don't know, just like these. We don't actually know if they're right triangles. It looks like they are, but we're not sure. They could be like 91 degrees or like 89.5. But they might not be 90 exactly, and they need to be 90 exactly in order to be right triangles. So, here's my thinking. I know there's a rule that we've gone over, or sorry, a theorem that we've gone over, and the theorem has a rule that says all triangles must be right triangles in order for this to work. And if you remember our friend Pythagoras, you will know that all triangles must be right triangles. And also the theorem states that a squared plus b squared equals c squared. Now, you'll have to excuse my penmanship. It's really not the best, but I do what I can. You're going to have to go with my verbal on this one because sometimes I can't write everything down. But we know that a squared equals b squared. A squared plus b squared equals c squared. We know triangles have to be right triangles for this theorem to hold true. So how does this work? Like, what do we, how can we use Pythagoras or Pythagoras? I like Pythagoras, it just sounds funner, to our advantage. The pen kind of changed orange there. I don't know if you guys saw that. That was kind of weird. I hope it doesn't like fade away. Anyway, so what I'm thinking is a lot of these numbers are whole numbers. We have a 9 here, a 9 here, a 15 here, 8, 6, 5, 10, 5.4 is not so fun, but 9 is better. These are all fractions, but they're only halves. But if one of them is nice and even, let's find out what the square of that is. Let's find out what the square of 91 is. If you haven't memorized, good for you. You're already screaming 91 at your, or 81 at your screen. Whoa, that's embarrassing. But I know it's 81. So let's pull up our calculator and let's say, okay, what's 9 squared? 81. Okay, that's c squared. So it has to equal, whatever this is, a squared plus b squared has to equal 81 on the right-hand side. So I want this squared plus this squared equal to 81. Not equal to 9, although we could find these two added together, and then we could take the root of it, and we could find out what this is. But it's just nice to know that this squared equals 81. Okay, whoops. Can you tell I haven't done this before? Okay, now, let's do that. 5.4 plus squared plus 7.2 squared. Not 5.4 plus 7.2 squared. 5.4 squared plus 7.2 squared. Another hint that I have for you is get to know your calculator before your exam. Use it lots and lots and lots. The calculator that you study with is the calculator that you should take into the exam. No exceptions. 5.4 squared plus 7.2 squared. That's not our final number. Equals. Whoa, look at this, 81. Well, that's the number I was looking for. How handy is that? Okay. Well, I guess I got it right. Well, I guess that's a right triangle because this squared plus this squared equals that squared. And Pythagoras states that that must be a right angle triangle. Well, let's try one of these. Okay, well, I can actually do some of these in my head. 6 squared is 36. 8 squared is 64. Oh no, that 4 and that 6 are going to equal... Oh, but 36 plus 64 equals 100. This plus this equals 100. That's way more than 9 squared, which is equal to 81. 100 not equal. That's an equal sign upside down and then crossed out. This is getting a little messy. I'm just about done with the question, I promise. But do you see how I squared this and I added the square of this, a squared plus b squared, and it was not equal. It was found not to be equal to c squared. And therefore, I know this can't be a right angle triangle because Pythagoras states all triangles involving a squared plus b squared equals c squared must be right angle triangles. The only reason I did this one is to prove to myself that this one was true, or could have been true. If I also found that this squared plus this squared equals that squared, then I would have been in trouble. I would have been like, oh, the rule that I was thinking of wasn't quite right. If you get one right, always try to look if you have time for one that's wrong. One, because it feels better. You're just kind of like, yeah, that one's wrong. But then also because it's super handy because if you know you found one right and one wrong, then you're following some kind of pattern. Math is all about patterns, but the pattern that you're following is more likely to be correct. Okay, so now I did 32. I'm feeling confident about it. I think it's A. It's definitely not B, and we could do C and D, but I know it's this one, and there's only one correct answer, so let's just say it's not C and D. Let's not do all that work. Let's go to our answer page. These are our answers. And I'll just do a quick introduction of this here. So this is actually very, very specific. It shows you how many questions are weighted per category of question. What's called knowing questions are typically a bit easier. Applying questions are about mid-range. About half the test is mid-range questions. And reasoning questions, those are our tricky questions. Only 13%. They don't come along very, very often. We're going to tackle one today, but they require some reasoning skills as opposed to just knowing what things are skills or application skills, I suppose. And then our topics, measurement, geometry, numbers, and algebra, are all weighted here. They're all weighted within the test. Integrated means just this topic, algebra, is dispersed throughout the test, mainly because algebra can be used in number, geometry, and measurement. But other than that, it looks like our highest weight is geometry, which is great because that's what we're doing right now. So anyway, let me skip down to question, that's just a bit of background. Let me skip down to question number 32 is what we're working on. 32. Okay, 32. Answer A. Booyah! That is indeed what I had determined. It's an applying question. That means it's mid-range. And numbers here aren't a big deal. They represent how many marks you receive for it, topics throughout the prescribed learning outcome. The PLOs are the prescribed learning outcomes. That's what you have to learn during the year, or your teacher is mandated to teach you. And it comes under PLO B4. If that doesn't really mean anything. If you want, you can go through all the PLOs. Sometimes teachers even give out the PLO sheet, and they say, here's what I've taught you all year, or what the ministry said I had to teach you. And you can make sure that you know everything before the test, which is kind of nice. But it's under B4, and it's a MC question. That's multiple choice. So anyway, we got that one right. Yay! Let's skip down to our reasoning question. That one's tough. Now, did you see that? I looked at the answer. I shouldn't do that. Okay, but that's fine. I can reason out some things, and I can prove to you the answer. Oh, yeah, this one. Okay, I really like this one. This one's fun. This one, what they do, the reason I think they call it a reasoning question is because the question itself is really, really scary. Consider the similar triangle shown below. Select the relationship that could be used to generalize the formula for the tangent ratio angle of A. Tangent ratio. Generalize the formula. Select the relationship. What are they talking about? Okay, well, let's do that thing where I underline all the keywords, which I just started. Okay, consider similar triangles. So these are similar triangles below. That's nice, and we know that because they share this line, they share that line. Select the relationship. That just means something equals something else. That could be used to generalize. That word doesn't come up too often. We'll talk about that. The formula for the tangent ratio. Tangent ratio. Well, we've definitely talked about the word tangent many, many times. We know tangent from TOA, as in SOHCAHTOA, our friend SOHCAHTOA. But tangent ratio for angle A is right here, I know that. But, what is this all about? Okay, let me read that one more time. Consider the similar triangles shown below. Okay, I know I have a bunch of similar triangles. Select a relationship that could be used to generalize the formula for the tangent ratio for the angle A. Okay, well, I'm still a bit confused. So what I do now is I look down to my questions. Look down. Oh, I see. So they're showing line segments here like BG, which is this one, and AG, which is this one. And they're showing AB, which is this one, and AG, which is this one. And they're showing a bunch of line segments and how one over another equals something else. One over another can be expressed as a ratio as well, right? With these two little dots. You could say like A, B, A, G, right? Okay, so ratio. So tangent ratio, okay. Generalize, that's kind of, let's leave that one for now. Just a sort of a general hint, general hint for generalize. Generalize just sort of means apply to a bunch of different things. So what can we apply to all the triangles? They actually use something that includes all of them, so it's only kind of generalizing. But anyway, that's just my beef. Sometimes questions have funny words. Generalize just happens to be one of them. But as long as we know that we're dealing with similar triangles, we're looking for a relationship with an equal sign. We've generalized the formula, and these are some of the formulas. These are all our options for formulas, if you will. The tangent ratio for the angle A. Well, tangent's to do with finding, if we wanted to like find the angle of A, we could use that tangent. We could use the inverse and calculate it, but we don't have no numbers. But all we're looking is to generalize a formula to find something. Oh, man, every time. Okay. Well, let's just reason this one out. Reasoning skills. Let's start with C. BG equals CF equals DE. That is ridiculous. That's preposterous. Do you know why? Because as this one gets wider, I mean, this has some angle, right? That means that this shoots off into the distance. It actually sort of goes on forever unless there's some sort of stopping point. But let's just say it goes on forever and there's always line segments. They will always get bigger because this line is always getting further away from this line. These lines can't be the same. They're definitely not. That is preposterous. And I am offended that C is a possible answer. Okay, I'm not, but, you know. Okay. Triangle ABG, similar triangle ACF, similar triangle ADE. Well, ABG, ACF, ADE. That looks about right to me, actually. So let's keep that one, let's put a little check mark by that guy, because that seems correct. The check mark doesn't mean that's the answer I'm choosing. It just seems correct. Okay. AB and AG. AB over AG. That ratio is the same as AC over AF. Is the same as AD over AE. Well, that seems correct. Cross that out so as not to get confused. BG over AG, CF over AF, and DE over AE. Well, all those seem the same too. The ratios, I mean they'll divide out evenly because this gets bigger, like this next one's bigger, but then this line's longer. So we can sort of reason out that those ratios will actually, each of these ratios will be the same, and these triangles are similar. So we have three answers that all seem kind of correct. But wait, let's go back to our question. Consider the similar triangles. Well, we know they're similar triangles. Okay, it's like the relationship equals that could be used to generalize the formula for the tangent ratio for the angle A. Well, this is an interesting one. You know, we already know this. We already know they're similar triangles. ABG equals ACF equals ADE. We know that. And they're asking for something about a tangent ratio. Well, I'm going to roll this one out. I don't think so. Because we know that they're similar triangles. It says it right here. And as well, it has nothing to do with a tangent ratio. It just says it's not C, it's not D. Now, these two questions each have to do with ratios. That's for sure. We know that. Oh, wow. Huh. Okay. They have to do with ratios, but which one? Huh. Okay. So here's what I'm going to do. I'm going to focus on our key word. Our key word is tangent, or key term is tangent ratio. I've sort of circled it or underlined it a bunch of times, but it is very, very key in this question. We're looking for the tangent ratio. We're actually looking for a generalized formula for the tangent ratio. What do we know about tangent? Well, something that we know is that in order to calculate something like the angle A, we need opposite over adjacent. Oh, opposite over adjacent. Okay, well let's take a look. AB over AG. AB, that looks like a hypotenuse because it's directly away from our right angle, over AG. Hypotenuse over adjacent. Okay? AC over AF. Remember, our angle of reference is A. That's extremely important. That's why I underlined it, and that's why I put the little angle there and circled it. Angle of reference is A. AC over AF. AC, hypotenuse again over AF, adjacent again, and hypotenuse again for AD over hypotenuse again for AE. So this one seems to be hypotenuse, oops, hypotenuse over adjacent. Okay, well, actually that's not what we're looking for. I bet A is what we're looking for. Let's see if that's right. BG over AG. Opposite over adjacent from reference angle A. CF over AF. Opposite over adjacent. Remember, because I'm working from A now. CF over AF. DE over AE. Yep, this is it. I have my opposite over my adjacent, which is exactly what I want, which means A is the answer. And as we've already seen, because I sort of looked, A was indeed the answer. Now that is a reasoning question. If that one doesn't come to you right away, no worries. It's actually not supposed to. Most people won't get it right on the exam. But if you can knock these ones out of the park, that would be unreal. They're worth the same marks as every other one. But as you noticed, I spent a lot of time on this one. I think I read that question about 6 or 7 times just as I was explaining it. If I was sitting in a silent room writing an exam with 3,000 other people, I would probably read that question about 10 or 12 times just to make sure I have it right. But use my method, underline keywords, go back, use words that you know to be the same thing, like relationship is an equal sign, formula means something will equal something, etc., etc. Tangent ratio here was our super key word, but also the angle A was important. Okay, and that's all I have for you. So I hope that you're able to navigate and find a couple past provincial exams. I hope you're able to pull them up, print them off, and go through all the answers. I would recommend going through all the answers and then checking them here. It's often, I've wondered myself in the past if the answer key is wrong on certain things. The answer key is pretty much never wrong. So it's something that you're doing. Sometimes that's a tough one to swallow, but you know, them's the breaks. All right, it's been a slice.